reality, we're just doing a couple of these examples just to kind of get the juices flowing, so to speak. Yeah. Mm-hmm. All right, so we're just going to do like 2 or 3 of these just to kind of get the juices flowing. So let's look at the first one. So 3/4 minus 1/8. All right. When we add or subtract fractions, what's the one thing that we have to have when we add or subtract fractions? Maddie, common denominators. All right. So this is all about common denominators. So you'll find that when we do rational functions, that's the same thing. You need a common denominator. All right. So how can I change one or both fractions to have a common denominator? Multiply them. All right. Now, you can do this in several different ways. You can do it by finding the GCF of the common or the GCF of the denominators, or you can just simply find a number that you know is both divisible by 4 and 8 and then multiply to get to that number. Either way. So, what denominator do you guys want to shoot for? 8. So that's actually the GCF as well. So we're going to shoot for 8. So what would I have to multiply to 3/4 to get a denominator of 8? 2/2. So that would give us 6/8. And then 1/8 already has a denominator of 8, so we can just go ahead and do the subtraction. So in reality, what am I actually doing when I do the actual subtraction? I'm only subtracting the what? The numerators. So in reality, we're just doing 6 minus 1, which in this case is 5/8. And that would be your answer. So the perk of fractions is that you don't necessarily have to have the GCF on the bottom. You could have said, okay, I wanted to shoot for 16. So let's say if we shot for 16 as a denominator, what would I have to multiply to 3/4 to get a denominator of 16? 4/4. That would have given me 12/16. What about for 1/8? What would I have to shoot for to get a denominator of 16? 2/2. And that would have been 2/16. Well, 12/16 minus 2/16, that's 10/16. And what does that simplify down to? 5/8. So that's the great thing with fractions. You don't necessarily have to have the greatest common factor, but it helps because it just means you have less simplifying to do at the end. All right. But it would still work out to get to the bottom. All right. So let's try another one. So let's do this one. 2/3 plus 1/4. What denominator do you guys want to shoot for? Let's do 12. All right. So what do I need to multiply to 2/3 to get a denominator of 12? 4/4. So this would be 8/12. What about for 1/4? What do I need to multiply? 3/3. This would be 3/12. So I have 8/12 plus 3/12. That gives me 11/12, and I don't need to simplify anything. So that's our answer. All right. So that's essentially what we're doing with all of these. So that's why for you guys yesterday who did not have to take the ACT, that's why I was making you do that. Just so it may have been more elementary, but it was just to start getting you to think about that process. Because the process for adding and subtracting rational functions is the exact same. All right. So now let's actually look at the more harder stuff, which is with the rational functions. So look at the graphic organizer that we were doing last week, so that yellow graphic organizer, and we're now going to do that backside. Now, before we do some of the examples on that, I also want to look at some very easy monomial ones. So that second sheet that was on that packet, that was what I had you guys do for that. So let's say that you had 4 over b plus 5 over a. And I asked you to add these two rational functions together. So think the same process as with the fractions. What's our goal here? We want a what? We want a common denominator. Well, if we don't know what these denominators are, what's the easiest way to get a quote-unquote common denominator? What'd you do with when we had a denominator of 3 and 4, essentially? You just multiply them together. When in doubt, multiply the two denominators together. That will give you a common denominator. Because obviously, if we do b times a, that answer would be divisible by a and divisible by b, because we multiplied them together initially. So, my common denominator, or my CP, would be b times a, or ab. All right? So, we're shooting for denominators of ab. And you guys might want to write this down somewhere, maybe like up top. So we're shooting for 2 denominators with an AB. Now, this is a game of what's missing, all right? So for this first fraction, what do I need to multiply to the top and the bottom to get that denominator of AB? Yeah. A. So we're going to multiply the top by A over A. So what's A times 4? 4A, and then A times B is AB. What do I need to multiply to the 5 over A to get a denominator AB? B. So we're going to multiply B over B. So this would be 5B all over AB. Now the great thing is that once you have a common denominator, you can write this entire expression as one fraction, kind of like when we did the multiplication. All right? So we can write this as AB, and then we have 4A plus 5B. Because remember, we're just adding the numerators when we combine these like terms. Now, are 4A and 5B like terms? No. So in reality, this is our answer right here. We're already done. All right? So again, that's why I'm like, okay, you need to know how to add and subtract basic fractions, because it literally translates into the harder stuff. That's why it's so important to have a good foundation of the basics, because it translates when you start doing the harder stuff. It's the same process, just a bit more work to it. All right. Let's try another quick one, real quick. So let's do let's do 4 over a squared times 1 over 3ab. All right. So not multiply. Minus. All right. So, what do you think my common denominator would be in this case? It doesn't have to be the greatest common denominator, but it can be a common denominator. Not A. So it's a matter of what's missing. What's missing from here that this one has? A B and a 3. What about this one? What's it missing? A square on the A. So what do you think the common denominator is? 3A squared B. Because this one's just missing a 3 and a B. This one's just missing another A. All right? So that's another way you could play that, what's missing. All right. So if we have that, we have 4, or no. So what would I have to multiply to 4a squared to get this in the common denominator? So we're shooting for 3a squared b minus 3a squared b. Play into the video with those forget. So what do I need to multiply to the 4 over a squared? What do you think? What's missing? 3b. Good. That's what's missing. So 3b over 3b. So what's 3b times 4? 12b. Good. All right. And then what's missing from this one? What would I have to multiply to this fraction? Just an A. Good. As y'all can tell, I'm not afraid to kill a bug. So, we want our denominator to have an A squared. That means we need to have 2 A's. This one only has 1, so we got to multiply another A to it. So 1 times A is just A, and then we still get into 3A squared B. Then we just write it out as if we're just subtracting the numerators. So we get 12b minus a all over our common denominator, which is 3a squared b. Now, is 12b and a common terms or like factors? I mean, like terms, Lord. I was talking about factors with my freshman, so it's just that's the word he's sticking today. Are they like terms? No. So we're done. Bada bing, bada boom. That's how easy it is. All right. So it looks complicated on paper, but in reality, it's a game of what's missing. All right. And that's what we're going to do with these harder examples. We're going to have to factor the numerator denominators first. That's probably going to be the hardest part. And then after that, it's a game of, okay, what's missing from this denominator between this denominator and this denominator? What's missing? What can I add? And then go from there. All right. So let's look at some of these examples. So again, same process that I just talked about. With addition, we would find the least common denominator. And again, you don't necessarily have to find the least common denominator. You could also just find a common denominator. As long as it's a common denominator, it'll work. It just means that you'll have more simplifying at the end. All right. So if you find the least common denominator, that's great. But if you can't find it and you just end up kind of multiplying them together, that's fine too. It just means that you just have a little bit more to simplify at the end. All right. It will still end up at the exact answer. Then you got to rewrite each fraction. And then remember that if you have a over b plus c over b, you can rewrite it as a plus c all over b. And then you just combine your like terms. So let's look at some examples here. So the first thing we got to do is factor our denominators so we can find the common denominator. So if I factor the first denominator, so the leftmost denominator, I still have the x minus 3 on top. What are 2 factors that multiply to give me 20, but add to give me negative 9? So what are some factors of 20? Just start naming me some. 5 and 4, what else? 10 and 2, what else? 1 and 20. Which one of those could potentially add to give us negative 9? Negative 4 and negative 5. Good. So we will literally write our factors as x minus 4 times x minus 5. That's all we got to do. Plus, we still got the 2. Now I need 2 numbers that multiply to give me 8, but add to give me negative 6. What we got? So negative 4 and negative 2. So this would be x minus 2 times x minus 4. Now, we got our factors of both denominators. So now let's try and find the common denominator. So let's play a what's missing game. So look between the two denominators. Between the two denominators, what's missing from x minus 4, x minus 5, if we're looking at both denominators? What's it not have between this one and this one? What's it not have? X minus 2. What about this one? What's it not have? X minus 5. So what do you think the common denominator is? Well, x minus 4 times x minus 2 times x minus 5. That's our common denominator. Because that's what we know is missing. So if we know that they have the x minus 4 in common, and this one's missing an x minus 2, this one's missing an x minus 5, that means our common denominator that we want to shoot for is this whole thing. Now, the great thing is that you don't have to box method that just yet. We're going to leave it in factored form for the time being. So if we're shooting for a common denominator, I'm just going to go ahead and write x minus 4 times x minus 5 times x minus 2 plus x minus 4 times x minus 5 x minus 2. All right. So you told me that the first fraction is missing an x minus 2. So what do you think I'm going to multiply the top and the bottom by? So in the leftmost fraction, so this one right here, what do you think I'm going to multiply the top and the bottom by? What's missing? X minus 2. I want to multiply the top and the bottom by x minus 2 over x minus 2. So this would be x minus 2 times x minus 3. All right, we're just going to leave it like that for right now. We'll save our simplifying for the end. Then, what do we need to multiply over here? What's missing from the denominator? X minus 5. So we're going to multiply x minus 5 over x minus 5. So we get 2 times x minus 5 on top. Now, we're not going to combine them just yet into one fraction because you may think that you just go ahead and simplify these, but remember, if you simplify them by crossing out, what's going to happen? So if I cross out these two x minus 2's, what do I get? What we started with. So don't simplify just yet. What we want to simplify now is we just want to multiply through these two values. So then when we rewrite it, we can start combining the like terms. All right. So we're going to do a quick box method for the first numerator. So x minus 2, x minus 3. So x times x is what? X squared, negative 2x times it. I just gave it to you. It's negative 2x. What's x times negative 3? Negative 3x. Negative 3 times negative 2? 6. And then when we pull it out of the box and combine like terms, I end up with x squared. Negative 3x minus 2x is negative 5x plus 6 all over x minus 4, x minus 5, x minus 2 plus, boom, boom, we just distribute 2x minus 5 all over all that mess. Not minus 5, it's minus 10. I could see the look on your faces that I screwed up. All right. Now we're going to combine all of the numerators into one big fraction. So we're going to rewrite this as our denominator is still x minus 4, x minus 5, x minus 2. And then we got x squared minus 5x plus 6 plus 2x minus 10. Now what do we need to do in our numerator? Combine the like terms. So my like terms are my x's and my constants. So I'm going to go ahead and combine those. So once again, I'm going to rewrite all the mess. So this will be x squared. Negative 5x plus 2x is negative 3x. 6 minus 10 is negative 4. All over x minus 4, x minus 5, x minus 2. Now, we're still not done yet because like any fraction that we add or subtract, we always want our answer to be in what form? Well, think about when we're doing fractions. So when we did the fractions here, what were we shooting for? Our answer to be simplified. So now we need to make sure that this rational expression is simplified. So I actually got to factor the numerator again, or see if it's factorable. Because if it is, I may be able to cross some stuff out between the numerator and the denominator, like we did in our earlier lessons last week. All right. So what are two factors of negative 4 that can add to negative 3? Negative 4 and positive 1. So this becomes x plus 1, x minus 4, all over x minus 4, x minus 5, x minus 2. Do I have any common factors between the numerator and denominator? The x minus 4s, so those are gone. So I'm left with x plus 1 over x minus 5, x minus 2. So we know it's simplified. Now I just got to clean it up. So all I got to do is just do a quick box method or FOIL to the bottom to get my answer. So I'm just going to do a very quick box for you guys just so you have something to reference. I told you it's a lot of steps. Uh-huh. I'll tell you right now, you'll never use this in the real world unless you're an engineer, but you're going to need it for Math 4. Well, you need it for the EOC if you want to pass.
I'm really good at guessing. So.
Well, I'm going to show you all the Desmos tricks too, so you'll be fine. But you just got to suck it up and learn it. So, you just got to learn it to appease me. So, this would be x squared minus 7x plus 10. And finally, we have arrived at our final answer.
I need to wait there for like 5 minutes.
I told you guys this is very step heavy. It's a simple concept, but the amount of steps is what kills people. Do you need a sticky note or something?
No, I've got it.
All right. So yeah, like I said, it's a pain in the butt, but it works itself out. Yeah, plus 10. So yeah, it's a whole lot of steps. Like it's murderous with how many steps there are. But if you just take it one step at a time, it's not bad. Yes, sir. I got to figure that out because we got behind 2 days because of me being out on Monday and then the ACT. So I got to figure that out. But I'll let you know. I'm guessing within a week and a half max. So somewhere around that time. That's kind of what I'm looking at because I know we got about 2 or 3 more lessons left in this unit. And some of them may span a couple of days. So, yes. Yeah.
Particularly like happening tomorrow or not?
I think the makeups are happening, but that's about it.
So will that affect us?
No. The only thing it'll affect is there won't be any bells. All right, guys. So let's try another one. This one's now subtraction. Just go ahead and brace yourself. This is what we're doing today, unfortunately. This is the one lesson that like I won't beat it with a dead horse. I'll show you how to answer these when you get to the EOC because it's really easy to figure it out in Desmos. What the heck, Haley? All right. So let's go ahead and factor our denominators. So let's go ahead and factor our denominators. So if I'm factoring my denominator, the first one, what's special about the first denominator? It's a difference of squares. So how do I factor it? Take the square roots and then do what? Right. We separate one of the two square roots by a plus, the other one by a minus. So what's the square root of 4x squared? 2x, so that's what goes first. Square root of 1, 1. And then we still got the x plus 3 on top. Minus 4 all over. What's the only thing I can factor out of 10x plus 5? A GCF of 5. So I'm going to take a 5 and then leave me with 2x plus 1. So looking between my two denominators, what am I missing between the two denominators from my first denominator? What does this one lack that this one has? A 5. What about this one? What does this one lack that this one has? A 2x minus 1. So what do you think the common denominator is? 5 times 2x minus 1 times what? What do they both have? 2x plus 1. So your common denominator is what they both lack and what they both have. All right, so that's how you look at it. It's like, okay, what do they both not have? And what do they both have? So you always start with what they both have, and then you finish it with what one doesn't have, but the other one has. That's how you look at it. Does that make sense? All right. So we want all of our denominators to be 5 times 2x minus 1, 2x plus 1. Now, I'm going to go ahead and change this up top to a plus and make this 4 negative, just so I don't forget to do that later. When in doubt, just go ahead and distribute the negative to that first numerator, so it's just taken care of. So this will be plus negative, I'm not going to put that here, 5 over 2x plus 1 times 2x plus 1. All right. So now it's a what's missing game. So what's missing from the first green fraction that I need to multiply to it? A 5. So I'm going to multiply this fraction by 5 over 5. So this will be 5 times x plus 3. What about the second fraction? What's missing? 2x minus 1. So I'm going to multiply this one by 2x minus 1 over 2x minus 1. So this becomes negative 4 times 2x minus 1. Now, I'm going to skip a step and go ahead and write it as one fraction, but also just go ahead and distribute and write out all the terms. So we don't have to like rewrite it and then condense it. Just save you guys some space. So this is going to be 5 times 2x minus 1, 2x plus 1 on the bottom. If I distribute the first set, what do I get? So we got 5x plus 15 here. What do I get here? Minus 8x plus 4. All right, so all I did was skip the step where we wrote it as two individual fractions. I just went ahead and combined them just to save you guys some space. All right, you can always skip that step if you want to, but if you need to see it, that's fine as well. Still haven't combined like terms yet. So if I combine like terms, these are my first set. Here's my second set. So I end up with negative 8x minus 5x is negative 3x. 15 plus 4 is positive 19. All over 5 times 2x minus 1, 2x plus 1. Now, is there any way that we can factor negative 3x plus 19? Nah. So, since there's no way to factor that, we can now just distribute the bottom and get what we need. Now, here's a great thing about us already factoring. We already got we don't even have to do a box method for 2x minus 1 times 2x plus 1. Why? Why do I not need to go ahead and box these two? Why can I just go ahead and write an answer and then multiply that to 5? Look at what we started with. Look at how we originally factored. Is this not 2x plus 1 times 2x minus 1? Was it originally? 4x squared minus 1. So guys, if we already factored it, we're essentially working backwards to what we factored. Factoring undoes multiplying polynomials. So if we work backwards, we don't even have to do a box method because they already gave us the answer, 4x squared minus 1. So all we got to do is just do 4x squared minus 1 all times 5. And that's just an easy distribution. So my final answer is negative 3x plus 19 all over, what's my denominator now? 20x squared minus 5. And I'm done. So sometimes, guys, use the problem that you originally started with to your advantage, because it may be that you have to do less work than what you think you have to do because you already have some answers available to you. All right. Any questions on that one? So again, it's step heavy. It's a pain in the butt. It's just something we got to do. All right. Okay. Take a minute. Try letter C on your own. I told you it's a beast. This unit is just a beast. But when we get to the review, I'm going to show you all the tricks. Yes, ma'am. You lost it again?
Maybe. I don't know where it went. No, dude, it was in my Chromebook. And then we took the ACTs, I take it out of my Chromebook, and I have no idea where it went.
Invest in a binder, Madam.
Madam is crazy. Madam is literally binders over there in the box. You keep talking. Get your finger away. Get your finger away. Put your finger down.
Guys, solve the problem. Thumbs up if you're ready. You guys, one more minute. That's why I said you gotta be really good at factoring because it only gets worse from here. I will say that this is probably the hardest lesson in the unit. The other ones aren't bad. No. Stepwise, this is probably the one that's going to be the most step heavy out of any, out of any of the units. Like any of the units, this is probably going to be the most steps. All right. So for time's sake, I just got to show you guys the answer. I got that. So just, yes. I'm just about to go on break. So can you wait like 2 seconds? So if you need to copy that down, you can, but you should have figured out that your common denominator is x plus 2, x minus 2, x minus 10 if you factored it correctly. You would have to multiply an x minus 10 to the first fraction, x minus 2 to the second. Remember, it is subtraction, so I just went ahead and moved the negative up into the 6 and changed this to a plus. I distributed, and that's how I got the x squared minus 10x down here, negative 6, distributed negative 6x plus 12. Combine the like terms, I got x squared minus 16x plus 12, which that's not factorable. So from there, I can go ahead and just multiply my denominators through. Now, since I know I got x plus 2, x minus 2, that's the same thing as x squared minus 4. I didn't even have to do a box method for it. You can if you want to, but if you want to save some time, I know it's x squared minus 4. So all I got to do is just multiply x minus 10 to x squared minus 4, and I get x cubed minus 10x squared minus 4x plus 40. Yes?
Almost. Is it mine still? Because I'm confused about the factors for the second one. Because if we're trying to get something that's negative on the positive, it can help be negative 10.
Because what's 2 times -10? Oh, you gotta be kidding me. I did it wrong. Son of a biscuit. Give me a second. So the common denominator is still the same. It's just that should have been a x minus 2. That should have been x plus 10. So actually the common denominator is different. You know what, guys? If you did it, good job. I'll fix it later when I post the notes. All right. So we're gonna do more practice on this anyway, so don't worry about it.
Okay, so everything I just copied down, I think, right?
Yeah, just copy down later when I post the notes. I'll fix it in post. Okay, so go ahead and take your 5-minute break. If you need to use the restroom, just be back before then. And then if you're staying in here, just go ahead and take out your Chromebook, log on to Delta Math. We're going to do a couple more problems together. So go ahead, take your 5-minute break. I'll go ahead and start the timer.
Why are you so cold? You sassy today. It's cold.
So just be back before that timer goes off.
I did not make it cold.
Son of a biscuit. I cannot believe I did that. Ugh, I hate it when I do stuff like that. That's plus.
I don't feel that bad. I've seen. I'll tell you right now, it's turned into a whole, like, there's a whole page of a packet wrong.
K minus. So that'll be plus. Uh huh. What do you? I don't. I'm.
Who made that many messages? You see the reason I asked that too, was because
Okay, yeah, that makes a lot more sense because now some stuff can factor. I thought I did that wrong. Ag flabbit. Okay. So you're just.
It's my favorite thing ever.
Well, I'm not getting in trouble for something like that because I can cuss like a sailor, so I really have to catch myself. X plus 6. 6 minus 2.
Oh, yeah. I would not expect anybody who's been in the army or anywhere near it to that.
And I feel like they don't fight that one. Oh, definitely not Marines. They curse at them from day one. They make them regret even coming out of their mother's womb.
Oh, yeah.
They didn't want to cuss at us when they see we looked at us and called us communists.
How'd you guys uniform inspection go?
Other people,
I'm assuming that's a good thing.
other people got the
I didn't get a 3 on a uniform check.
somebody.
My brother used to. He's the very last.
Okay, is that what you got, Tomas? Okay, that makes a lot.
You know the long hallway in the very last picture, the very last
Son of a biscuit. I hate
You're going like down the hallway.
Okay, so the very last one.
The very last one this way.
Okay.
And if you look and you see Logan Cape, that's my brother. That was from like 3, 4, 5 years ago.
We had some cats today. 4 years ago. He was here today.
I wanted to do in our like if I'm gonna join the army, I'm gonna be in the Marines. I'm not doing the Navy.
I would honestly go to service later on. Get a better right.
My dad joined the Marines. And my dad told me he was like, if y'all didn't start cussing before you were 10, I would be surprised because I was in the Marines. We cuss all the time. I was like, yeah, because it's like every other word.
Yeah.
every sentence has to end with a word. Never does it end in a regular word.
That's.
What is it? It's crazy.
It is very cool.
Says the guy in full uniform.
At the end of the day.
Like, After you get stuff, you get there.
When I get home.
So guys, take your Chromebooks out, get on log on to Delta.
I'm not
That's
going.
where we're gonna start.
Where you go?
I drive.
You're gonna do driver's ed, huh? Oh, wait, are you driving?
Yeah. I wish it was a second. So I was the first and I was second.
Oh. Mr. McAllister called me kiddo today. I was like,
What's he like?
no, he do third notes. He's still serving. So they usually get out. Well, Mr.
So
McAllister.
guys, go ahead and get your Chromebooks out, log on to Delta Math. We're gonna do a couple of problems together just to make sure you guys are fairly solid on this. So you may want a sheet of paper just so you can just do scratch work on. Because I will go over like literally some of these Delta Maths.
Did she need a 15 hour?
Yes.